Okay, in this video I want to continue with these limits at infinity, and especially talking about some of these trigonometric limits here. In the next video I will talk about limits of trig functions, and you shouldn't confuse the limits of trig functions, especially around values like 0, where there are special limits, with these limits as x goes to infinity. Don't confuse those together. So what's happening in number 29 is that the denominator is growing extremely large, and it's going to keep getting larger and larger. The numerator, however, the sine function oscillates between -1 and +1. And so just by multiplying it by 2, sine of 2x, all that's going to do is stretch it out, and that's going to affect the period of the sine function, but it's not going to affect the amplitude, how high or how low the sine function goes. So the numerator is going to stay constant between, it's going to oscillate between -1 and +1, while the denominator keeps growing larger and larger and larger. And so what's going to happen is no matter what the value of the numerator is, the ratio is going to approach 0. In the second example, number 30, it's probably best at this point to split up the x minus cosine x over x. I think we've talked about the hard shape there. We can split this up into two separate fractions. And when we do that, the x over x becomes 1. The cosine x, again, is going to oscillate between -1 and +1, while the denominator x is going to grow without bound. And so the cosine x over x, as x goes to infinity, becomes 0. So as x goes to positive infinity, the first term x over x goes to 1, the second term cosine x over x goes to 0, and so the final answer there would be 1. All right, number 31. Here we can't do that. We can't split them up. It doesn't make the hard shape. It's an upside down hard. So as x goes to infinity, 2x is going to become huge. Sine x is going to oscillate between -1 and 1. So it's not really going to add or subtract that much. The 2x is the big piece here. And since the degree of the numerator is 0, it's x to the 0 power in the numerator, this one is going to go to 0 also. And finally, as x goes to positive infinity, the limit of cosine of 1 over x is going to grow without bound. 1 over x is going to become tiny, or become 0, and cosine of 0 is 1. So the limit of that piece is 1. Alright, so here are some examples. The middle piece there, 25 through 28, to do this algebraically is the most complicated. What you have to do for those types of problems is, first of all, you have to note whether your x is going to positive infinity or negative infinity. The second thing you have to note is the coefficient in the numerator. In these problems, it changes from 1, 1 to -3. But you also have to look at the coefficient of x squared in the denominator, and you have to take the square root of that coefficient. In these examples, they're all the same, but if there was, for example, a 2, square root of 2x squared in one of them, then the coefficient of the denominator would be square root of 2. And again, these problems only work when the degree of the numerator is 1, where you have x as the highest power in the numerator, and you have square root of x squared in the denominator. You still take the ratio of the leading coefficients, but you have to look at whether x is going to positive or negative infinity. Alright, so that's it for that particular topic.